webinar session of ours. So calling it as Mastering STAAD.Pro Advanced Techniques. So as you already know that it is like STAAD.Pro, we do the modeling, analysis, and design. So here we are here to just improvise, like, or maybe learn what exactly the advanced techniques holds. And also many of our customers, or it might be any clients who are working upon the softwares, do have a doubt always saying that what is STAAD.Pro and STAAD.Pro Advanced? What exactly, what are the kind of the features which the Advanced has that we have to go on to that? Or why we'll have to just purchase that, software within our workflows, right? So today we will be just looking on to one of the um, typical parameter which we always just differentiate between a linear and non-linear analysis. So we'll be just getting to its insights and learning what exactly and how exactly we'll have to just develop those kind of the parameters in our workflow. So let us just go on with this methodology of what exactly does it mean. So, if I have to just introduce myself, so I am Bhargav Srinivasa. I'm a senior solution consultant for structures. I do take care of the products which are related to the Bentley, that is structural work suite. So we have both the STAAD as well as the RAM family. So I'm based out of Bangalore, and I'm already nearing 2 years at Arcans. So I've, in this 2 years, I have conducted various workshops. I have also conducted workshops at IIT Dharwad, and I have also conducted training for various government organizations. So very recently, I had been deputed to IOCL, that is Indian Oil Corporation Limited, where they had a 10 to 12 days training program which held at Noida, Delhi. And also in this, I do solve the technical glitches of the software. So here, much more of the participants who are here also would have known by, me meeting through the remote sessions, or you might be just looking onto the mails of mine. Yeah, I hold a bachelor's of civil engineering, and I have done my master's in structures. I've also had an academic exposure, before I just joined Arcans, I had an academic exposure of 8 years in premier institutions. Earlier to this, 8 years of exposure in academic, I was also a site executioner for various civil projects. So this is about me. So talking about this company, that is Arcans, we widely are served in the adoption of computer aided design solutions and their integrated workflows. We work with world-class software providers and intend to continue to expand our portfolio of the partner softwares. So yes, we are also called as the first global platinum reseller of Autodesk softwares. So, and we are also a trusted partner for the leading software in the construction, manufacturing, and infrastructure sectors. We have a best-in-class, unique in the industry team of 40 plus, service professionals across the India. Also, we deliver our own software solutions as well as training and professional services to our customers. So when we say that we have our own software solutions, such as we have a Holixa T4R and tools for Revit, as well as for the implementation of the manufacturing workflows. So our services portfolio are we are a software consulting partners, and we have the core services, which is we just provide the customized support. We are we have the instructor led live self-paced and online training programs, and we also have a BIM consulting team in our house. And we also think future of the framework, where we just deal with sustainability and digital advisory services. So this is about our company prospectus. And further, when we just move on to our exact program, so what and why many people are here for. So this is how my agendas are aligned to this to this webinar session. First, we need to just know the importance of the advanced analysis. So why advanced analysis? Then we just speak about the nonlinear analysis overview. We also spot the difference between this linear and nonlinear analysis methods. We also speak about the types of the nonlinearity, and we'll be able to differentiate between what is a geometric nonlinearity and material nonlinearity with a few examples, and also when to use this methods in our workflow while we just develop the model. And also there are key challenges of analysis methods, like what analysis methods that you'll have to use onto your workflow. So you'll be able to just identify when do you use such kind of a static or dynamic analysis onto your workflow. You'll be able to contemplate that. And finally, inside the STAAD.Pro Advanced, like we have a parameter, that is control parameter, which is related to nonlinear analysis, and how do one user input the changes over there, so that he'll be able to just plot a curve. He'll be able to see the stress or strain curve depending upon the material and the loading that he has deployed, right? So the next slide is about importance of advanced analysis. The first point is like we ensure the structural safety and performance under extreme conditions, such as seismic events. So we know the structure must withstand earthquake by incorporating ductile and detailing and seismic resistant designs. Yes, which the STAAD really helps us to just formulate by us just using the seismic, forces methodology. We have high wind loads. So buildings and bridges in cyclone-prone areas must resist this wind-induced forces. Call it to be a PB structure, call it to be a multi-storied RCC structure, call it to be a steel structure. We have the solutions, right? And also we have a one parameter that is an automated parameter of the wind loads for our own IS code, which you can just input the parameters and just simulate accordingly. Heavy loads and impact forces, yes. Industrial and bridge structures often experience sudden and dynamic loading conditions, such as vehicular or crane loads. So for that, we also have the kind of the parameters inside the STAAD.Pro, software, that it is vehicular definitions. So, and also the moving load concepts can be just utilized inside the STAAD. And at lastly, on the first point that we have, that material fatigue and aging. So we know over time materials degrade due to environmental exposure and repeated loadings. STAAD.Pro helps to simulate the material fatigue and aging effects, aiding in the maintenance and the planning and retrofitting. Addressing the second point, that is like, coming on to the below, we have addressing complex loading conditions and material behaviors like multi-directional loading. So due to the multi-directional loading from the different directions, such as wind, seismic activity, and live loads, STAAD.Pro provides multi-load cases analysis to access this combined effects. Sorry about that. Yeah. Just a minute. Yeah, sorry for the glitch. So variable and dynamic loadings. So bridges and stadiums, or it might be industrial structures, it needs to handle all the fluctuating loads from traffic machinery or wind gusts. So STAAD.Pro has time history method analysis, response spectrum analysis in the STAAD.Pro, which helps to predict the real-time behavior. Next, coming on to the advanced material loading. So non-linear materials properties such as creep, shrinkage, and concrete cracking significantly impact the structural behavior. So STAAD.Pro helps that engineers to model these effects for accurate design validation. So for this to happen, we have a bundled software that is RCDC, where we just move after analyzing and designing inside the STAAD, and then we'll be able to just contemplate this creep, shrinkage, and the concrete cracking parameters inside that, and we'll be able to just compare with our codes, IS codes. So the lastly, load path and distribution. So we need understanding how loads transfer through the structure is very critical, and we need to just prevent the weak points. So STAAD.Pro helps in identifying the potential failures zones and optimize load paths for enhanced safety. So these are the importance of the advanced analysis which we need to know just before we commence with our different types of analysis what we have inside our structure. So coming on to this nonlinear analysis, what is this nonlinear analysis? We know if it is a linear analysis, when we call it as a linear, we all have followed that our software practice by just finishing up our all the key inputs of geometry, loading the properties, materials, and then assigning the supports, loading. And then when we just move on to that analysis, we just go by this perform analysis method. So it gives a single run analysis where you'll be able to just distinguish what exactly is that error, what are the warnings that you've got, and then you progress it on. Suppose if you just take any material, whatever it is, a concrete or the steel, it gives you a linear kind of a graph, isn't it? So what nonlinear analysis is nothing but it is an advanced structural analysis method that considers large deformations and material behavior beyond the elastic range. So if you just take a steel, a steel rod, and when you just try to bend it, so the kind of the curve which it forms when you just are plotting it onto the graph, you'll be able to see that bend at certain point when it is converged. So that after the converge, what happens? It diverges. Then we just will term it is it is buckled. So that is a different scenario in the webinar series which we'll be having upon the buckling. Okay. So it is essential for structures subjected to extreme loads, ensuring safety and accurate response predictions. Yes, non-linear analysis, when we just speak about that, it's a repetitive analysis, right? We need to just follow the repeat loads inside this, unlike when we just follow through the methods of primary load, or maybe when we just combine the load using the load combinations, we just don't take the repeat load combinations inside the load combinations. That is purely, it is a single run analysis where it is only just by giving a factor, partial safety factors, onto the dead load, live load, wind load, or the seismic loads. Okay. So, okay, when we just go on to the difference between this linear and non-linear, when we know what is the definition of non-linear. So linear analysis, it's a single run, as I already say. And also in the industry, all our engineers, or maybe when we are, in the academic, days, we always term it as a single order analysis, or maybe we call it as a first order analysis, or we call it by second order analysis for non-linear, right? So in first order analysis, what do we do with that single run? By performing analysis, we calculate only deflection and not any movement, right? So in non-linear analysis, multiple runs are tending to happen. There are we call it by the name called a second order analysis. Here we calculate not only deflection, but also any additional movement which is tending to happen upon our structure. So with every multiple run, there is not huge kind of results what we'll be just able to expect. It's a very small change in the results which tends to happen after 4 to 5 runs, depending upon the load steps that we have provided. We'll just go on to that control parameters there. I'll be just letting you know what are that load steps, etc. So in second order, it is meaning a nonlinear analysis effects. It horizontal displacement take place in nonlinear analysis depending upon the load that you have ascertained. And also we call by another term, it is called as P delta analysis. So P is nothing but the load, which is a vertical load, and the delta is nothing but the horizontal displacement. So as I said, P delta concept, and the webinars also will be just upon that also in very shortly. I'll be discussing more in detail about P delta analysis in our upcoming webinar sessions. And also the materials, as you can just see in this tabular, material properties remain unchanged. Material properties can change. So when we say about the change, material properties changing, when it is a steel, we just always take the ductility or the malleability factors of that. So that is the meaning of that. And here support conditions are unchanged. Non-constant support behavior or the contacts depends upon the contacts. When we say about the non-linear contacts, the next example you'll be able to understand with the diagrammatic. Sorry, I have a picture for you. When you say about the contacts, it's either rubber medium, right? So the loads remain unchanged. The following are the following loads. So loads remain unchanged in the sense, in our regular practice, what do we do when we just go to the loading? We go to the primary load and fix our dead load, and we just give that different member loads, right? And we just don't go with any repeat load scenario. So only we follow with this, basic loading. So in linear analysis, you can just take down this also. In linear analysis, only traditional load combinations are used. Whereas for non-linear analysis, one would need to create primary load that cause that combined primary load cases, and it is made easier using the repeat load commands. Yeah. So this is the major change in this linear and non-linear about the loads. Further, as I just said you about the contacts, in the very next diagram or the picture representation, you'll be able to see this. See a condenser of a split air conditioner, which is mounted on the rubber mounts. So we know this rubber, it is a highly nonlinear material. So when there is a load which is tending to act upon this rubber medium, the load and the deformation will not be linear. As the deformation increases, the stiffness of the structure also increases, calling by the phenomena which is known as stiffening. That is stiffening of the rubber. Yes. So this is one example I can just give about the nonlinear. Okay. We have defined what is nonlinear. We have been, differentiated what is linear and nonlinear. And finally, we are looking on to this example, what is a nonlinear system looks like, right? So the next slide, what we have is about types of nonlinearities. Yeah. As I just mentioned, we need to just differentiate between this material nonlinearity and the geometric nonlinearity. Better we know what is the definition of this material nonlinearity. See, I've just got this material nonlinearity as metal forging over here, as a geometric nonlinearity hammock ropes, and the contact linearity, which is a gear meshing. See, when you just look onto this, what do you understand? See, I have also another, picture over here, which says about this is a material nonlinearity. The pictures, what you will be able to see is a material nonlinearity. What happens is, as you can just see this graph of stress versus strain, which is for the cast iron, it is never a linear. It is always a non-linear kind of thing. And when I just speak about the convergence, depending upon certain load, it converges over here. And after a while, after the fatigue, after material fatigue, what happens? It diverges, and there it forms a kind of a buckling. Okay. So when you just can see the next second picture over here, it has reached the yield point. What the sheet metal has reached the yield point, and therefore it can never be a linear function. It's a non-linear example. And coming on to this material nonlinearity, coming on to this second part of this example, that is geometry nonlinearity, you can see the hammock ropes. See, at the beginning, you can just see the hammock ropes which will be tied onto two ends. Okay, what happens is before that loading, it tends to be as a linear, but when there is a load which is tending to happen, you can just see a person who is resting upon this hammock rope. The deformations are large. When the deformations are large, yes, there lies STAAD.Pro, which helps us to just differentiate between the different loads which is tending to happen upon the structures, which will just provide us such a kind of a deflection what has happened upon the particular junctions or any necessary structural zone. Okay, so this contact non-linearity gear meshing, we just don't use this inside our STAAD, but still you just got one simple example of when there are two bodies. This is one single body which is a cycle tire which has a rim, and when it is released, what tends to happen? It forms two bodies. There's a brake medium which is one body, and the second one is a tire with a rim with a tire, which is the second body with that. So when it comes to the contact, it forms a contact non-linearity, right? So that is what I can just brief about this types of non-linearity is what we have. And now comes the next slide saying that when do you use this non-linearity? What are the key concepts in the STAAD.Pro? The key concepts in the STAAD.Pro is that stress and strain curve in STAAD.Pro material nonlinearity can be modeled by defining the material's behavior using a stress strain curve. Obviously, you'll be getting a stress strain curve once when you just enter into the mode of nonlinearity parameters. That is when you just analyze. When you go to the analysis print commands, you'll be able to see that stress strain curve. And plasticity models, STAAD.Pro uses advanced materials like von Mises criterion to account for the plastic deformation in materials like steel, concrete, etc. This is exclusively for the slab when we just do that analysis and design there. And failure criteria, yes, for the concrete, STAAD.Pro can apply failure criteria to model cracking, crushing, and other failure modes under extreme load conditions. Where do you see this kind of the values? Is it in the output? No. When you just move on to this STAAD.Pro Advanced feature, that is RCDC, you'll be able to just enter the parameters for the particular concrete member, that be it be slab, column, or it is a beam. You'll be able to just depict its values over there from that. Yes. When to use that? Material nonlinearity is essential for the structures subjected to high stresses, like in the case of earthquake loading, high wind pressure, or large concentrated loads which are acting upon that. Then this material nonlinearity application shall be applied. And then next, coming on to the geometric nonlinearity. So it also arises when large deformations so example for geometric nonlinearity, you already know that it's a hammock row. As you can just see from the you have already seen that previous slide what exactly it looks like. So when there's a body which tends come and occupies that hammock row, and with the greater deformations, what happens? It changes in the changes in the physics, like the shape of that structure changes. The key concept in STAAD.Pro for relating to the geometric nonlinearity, yes, the one such concept is the P delta effect. So P delta effects, it's used for the second order analysis for the tall structures, slender column structures. There you'll be able to just utilize this concept, which as I just already mentioned, saying that we'll be having webinar sessions related to this P delta concept. We'll discuss more in detail over there. And also for the large deflection theory, when displacement are, yes, I know there are some kind of the doubts where the participants are having. I'll be answering at your last 10 to 15 minutes. I'll give you time. Yes, Sachin. Yes, I'll give you time at the last. Yeah. Continuing with this, when to use this? Geometric nonlinearity is useful for tall buildings, bridges, and any structure subjected to large loads or the deformations. Okay. So that is about the material nonlinearity and the geometric nonlinearity. Okay. The next is, as I just said you, so we need to just choose an appropriate analysis methods. We got a key challenges in predicting what is the appropriate analysis methods that we have to use for the structure. When do you use what analysis is very important for us. Whether we use a linear static analysis method or non-linear static analysis or dynamic analysis method? When do you use it? See, key challenge is like choosing the correct equations to describe the physics. That is the first one. The second one is you know, we are. It's very difficult for us to get not difficult, but getting a realistic material data is quite a cumbersome process. The third point is now numerically solving the set of the equations that describe the physics of the problem. And once when you do that, dynamic or the linear analysis, interpreting the results of the solution is also quite challenge, for structural engineers. Based upon that, we have some 5 important types of the complexities commonly observed in the structures. That is what first is the change of the contact. Second is the permanent deformation, the non-linear material, time-dependent loading, and finally the inertia forces. Depending upon on this, we'll be able to just choose what is the appropriate analysis type that we can have. See, the first one holds that is nothing but when there's a change of the contact, we have a permanent deformation. When the material what we have used is a non-linear, and also there is a time-dependent loading with a very less or no high inertia force, then we need to use the method which is known as non-linear static analysis. And coming on to the second, when we have the change of the contact, permanent deformation, non-linear material also is used. We have a time-dependent loading. Also, we have high inertia force. High inertia force is nothing but what? High inertia that is related to the seismic, right? Seismic forces as well as wind force. Then we use the non-linear transient dynamic analysis. The third, that is, you don't have any change of contact, no permanent deformation, no non-linear material which is being used. Yes, there is a time-dependent loading and high inertia force is observed. That is nothing but we'll have to follow with linear dynamic analysis. And it is also called as what? Model harmonic spectrum or random vibration analysis. For that kind of a type, you'll be able to use this linear dynamic analysis. Okay. So the last part, that is, you don't have a change of contact, no permanent deformation, no non-linear material. So there is a time-dependent loading, but there is no high inertia force. So linear static analysis. We have already formed this equivalent linear static method, in our seismic practice, seismic kind of the structures. When you use this, we've already used this. So you can just take a snap of this also for your, understanding after the session also. You can just use it onto your workflows. The next is very important. So where do I get this tab? It is once after I finish the loading, when I just are entering inside the analysis mode, I just go to the analysis command, and there is analysis print commands over there. And below that, just before non-linear analysis, what were we doing? We used to go to the perform analysis over here, and we used to form a single run analysis, that is single order analysis. But here I've already you can just see that I have already directed to non-linear analysis, and these are my parameters what I get to enter. So the non-linear analysis parameters says about the arc. What is this arc? See, the first load step must be stable. If this is not the case, then the parameter ARC, that is arc, should be used to control and prevent the instability of the structure. So, in an easy term, how much is that absolute displacement that you want to provide to the structure is what you have to input. Suppose you leave it by 0. It's a default value. It gives you the random displacement what after the nonlinear analysis has been obtained. You'll be able to just interpolate that. But say, for example, if you're just mentioning something like 300 mm is your arc, 300 mm is the arc which is being set. Above that, you'll not be able to just contemplate. It will be just staying within that. So I mean to say, when you just move on to the arc, when you just give some numbers, and when you just rebuild the steps, and when you just give a target value below 300 mm, that is maybe you can just be mentioning 0.25, that is 250 mm. So between that, if there is an analysis which has to be performed, which is related to the nonlinear, it will perform. Otherwise, it will skip that part. Next, coming on to the iterations. This iteration is set to the maximum number of iterations, and this is with the objective of avoiding infinite number of iterations. By default, it is already 100, which has been shown. So what the user needs to do? He needs to check the maximum number which has not been attained. Otherwise, he would really increase this number, the iterations. Remember, more iterations, more analysis time. So if you're forming with the 5 iterations with the very smaller loads, yes, 5 iterations will be done. Yeah. And coming on to the tolerance, what is the tolerance? It's a criteria by which the program will decide the solution, whether it has converged or it is not converged, or there is a reasonable value which should be selected by the user to help the program converge. So when you see that curve, okay, when you see that non-linear curve, you need to just depict at what load is your material getting converged, means it is getting bent. So that is the tolerance value which needs to set. The load step, it defines a number of load increments. Higher numbers could help in the case of the large displacements or rotations, but higher number also means increasing in the analysis time. Suppose if I just mention load steps as 5, so I'll be seeing my non-linear curve in the 5 different load steps which has been obtained, which is applied to the structure. Okay, so I'll show you that what exactly I mean by that, in my next coming slides. So the rebuild steps indicates the frequency at which the solver will need to update the stiffness matrix. So the value 0 means that the update will only happen at the start of each load step. A value of 1, that means at every iteration, the stiffness matrix will be needed to update. So that is about the rebuild step. Okay. So you can just also see by side, like what it has been mentioned by rebuild says 1 frequency of rebuild. So the tangent K matrix per load step and the iteration. So using of this kg, yeah, this will be dealt even more better when we just are speaking about the P delta effect, where the kg matrix, when it has to be used, when it is not to be used, we'll be discussing in the next upcoming sessions. So what does a kg do? That kg lets the user decide whether geometric stiffness should be added or not to the stiffness matrix. So that is the meaning of this kg. So the next additional, things what you have is over here is parameters which are also which are available is node. What node that you want to just look onto the displacement. For example, if you mention some 8th node which has to be formed onto the degree of freedom of x-axis, what is the target value depending upon the arc what you would set. So you'll be able to just see for the particular node what is it displacement has been occurred over there, what it's been analyzed. So that says about this, control parameters. So the target value, yeah, once the target value is reached or exceeded, the load increment stops. Okay, so the load steps what you would have given will stop at that point, and it will give you that values. And the results are reported for the applied load. Okay, so this is about the control parameters, what you intend to use inside your nonlinear analysis mode. And once after you do that, the next formulation is what? Yes, post-processing results. So inside the post-processing results, you would have seen this tab, right? You would have checked your bending moment, shear force. You would have checked your deflection, displacement, right? So in the same way, you have something called as layouts, which you can just see in the geometric nonlinearity. You have for node displacement and for the beam forces. You will be able to just see how exactly is your load level versus displacement curves looks like, that stress strain. So specific layouts for the nonlinear analysis through which the user can display the graphs of the node displacement and the beam forces for each load increment. And also adding on to that, wherever you have, started your process of nonlinear model and analysis and design, in the same saved folder, you'll be able to see, there are 2 text files, txt files, that is nothing but one is for the displacement, another one is for the beam forces. So I'll be able to show, in the next slide also, that how exactly it looks. See, this is the file what you'll be getting, the folder where you have saved. So the joint displacements, and you can just see for the load cases, the step number 11, the percentage of load, which is 55%, 50%, no. And the next post-processing output file, number 2, that says about a non-linear member forces. So member 1, 2, 3, 4, that is all the beam, and these are all the sections, and with the joint number, you have the different loads for the step number 0. Next step number 1, you have this 5% of the loading which has been added, and these are the values which you'll be able to see. And also, roughly onto this, I have also got a model, formulated, where you have one portal frame, um, which you can just clearly see by the geometry. And what I wanted to just discuss over here is, main thing is about the two primary loads which I have developed, and also I have utilized a repeat load for me to just form a nonlinear analysis. Okay. So the nonlinear analysis, the type of this column height is different. So that's why I intend to use a repeat load for me to just abbreviate like how exactly my load level versus displacement looks like in the reports. So the use of the repeat load, and then comes this, in the analysis, what you after you provide the load, how you will have to utilize this. Um, yeah, how you'll have to utilize this, parts, that is the perform non-linear analysis iteration of that 100 steps, below that load number 1, below load number 2, and you need to change this also. Why is that change command used? The change will instruct the program to reset the stiffness matrix before it proceeds with the next load case. So for every load case, you'll have to provide the change. So that is what it has been done. And finally, when we just move on to the next slide, that it is, see, I've just shown for one particular node, and this is what the graph that I have got. And yeah, there's a lot of discussions which are related to the P delta effects, that is small delta, large delta, which I have to discuss, which is comprising of both beam as well as the column, where we just need to just interpolate about the camber, camber what it is, the drift what it is. Yeah, that is what will be dealing in our P delta. This is very basic, like, how exactly that we need to use this non-linear control parameters. That was actually the whole, part of the discussion was like. And coming on to this, you know, next slide, that as I just already mentioned, saying that you've got two text parts, which is over here, there, where you need to just take the details from there. Take the details in the sense the joint displacement as well as the member forces also. So I'll just do one thing. Before I just wind up this part, I'll just give you time for you to also to speak in the last 10 minutes. So I'll just take you to the model of what I had just a minute. Just a minute. Just hope you are able to see my screen. Could anyone confirm with the thumbs up? Hello? Yeah, sure. Thank you. See, that's what I just mentioned. See, there's a geometry and the properties, materials which I've specified. There's a supports, what I've given, and there is a loading part where I've already shown you like what exactly the loading looks like. I have provided the loading, FX 50 kilonewton meter, FX 75 kilonewton meter at the top, FX 100. Then also vertical load, which I've given for the entire span of this beam. And with that, what I have done is I just have moved into this, I've just created another primary load case. And in that, I have added this two repeat load commands. See, I just come onto this repeat, and I have made sure that I just have moved on to this end, and then I've added this and I've closed. That forms the set of the repeat load combinations for this part, where you had also seen in the slides that about the load combinations and about the repeat load, how it looks. Okay. Then moving on to the next, that is analysis. As you can just see, I'll double click upon the parameters what I have entered, and I have set my arc to be as 0, iterations to be this, and tolerance I have just left by default. And I've also provided the load steps as 10, and I have rebuilt the steps to be 1. And I have also used the use of the kg. I have included the geometric nonlinearity. Stiffness is also here. And yes, and this is what I've done. And when you just go into this analysis, you're running the analysis for that. Run on to the analysis, go to the output file, you're viewing the output file, and okay. See, this is what you need to just see. Just a minute. I'll rerun the analysis for you. Yeah, see, this is what you need to see. For example, the iterations, whatever the iterations, the 10 steps that you have given. So that has to be found within this. For the iterations has to be run for this only. For example, if you don't form this kind of iterations, then again, what the user needs to do is like you need to just increase the iterations for you to just form that convergence point for the given proper load. So I need to just go on to the further onto the post processing mode, and then move on to my layouts, and onto the layouts I'll come at bottom. I find the geometric nonlinearity. I've used the use of the kg. So here for the node displacement for any particular node, I'll be see for node 5, node 6, node 7. Can you see this difference? What it is tending to happen for the different nodes? Yes. And also, see, as I've already just provided 10 load steps, right? So you'll be able to see. Can you see this changes? Third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Yeah. So that's what I mentioned. There's P delta, so there's small delta and the large delta, which I need to discuss. I'll just take them on to my next coming session. That, and also I can just limit this, limiting the maximum load of the step of the graph. And what else is left? And yes, I'm moving on to the next beam force. So you can just see the beam results. You can just see the deflections, about all these things. But the main thing, as I said you, in the folder where I have saved, I can just move on to that particular folder where I have saved within our. Just share that also. I'll share the screen in a moment. Just a moment. Yes. Hope you are able to see this folder of mine, webinar. So I've stored this as geometric nonlinear analysis. You can just simply go by typing it as text, enter, and you'll be able to see this, right? So nonlinear member in the process, you can just, say to be open. Then yeah, here it is. See, for the load case one, step number 0, right? Arc, which has started with 0, right? 0. So percentage of load 0 and percentage of 10%, you get this fx, fy, mz values in this way. And these are for the members. And moving on further for the load step, load case 1, that is step 2, percentage of load, that is 20%. So you get this, you obtain this values inside this. And this is for the joint displacements. In the same way, 0, 10, 20%, 30%, 40%, 50%. So every time when you're just moving on to the next, set of the iterations, what you have just developed for the particular load cases, a very minimal changes has been obtained. Maybe for the fourth or the fifth iteration, you would have got the same value as it is. Again, it will be reiterating with the same, I mean to say the values will be recurred. That is what I mean to say. So this is what you can just do in this nonlinear analysis. And so finally, that is what I had from my end, and you can just post, or maybe you can just unmute your mic, and I'll be available for the question. Or if I might not be able to answer at this moment, I'll definitely just take your coordinates and just give you a valid, solutions for that for sure. So yes, just a moment. Yeah, yes. Thank you. And now I'm available for questions. Yes. Can someone unmute yourself and just, okay, I'll have to just give that access to you. Who is it? Can you please raise hand so that I can just see who has raised, and I'll just allow you to talk? Is it Sachin? Okay, fine. Yes, Sachin. Can you unmute yourself, Sachin?
Yes. Okay, Bhargav, I am having very basic questions. Actually, I would like to just means you have explained about linear and non-linear analysis, uh, and you talk about p delta. Actually, can you just means I have very basic question. I just want to understand. Can you tell me in p delta analysis what is p and why it is called as p delta analysis, and what
PP.
kind of
Mhm.
responses we get in p delta analysis?
Hmm. Yes, yes. See, the concept of P delta is very simple. See, the P is nothing but it's a vertical load, and the delta is the horizontal displacement. From the node, how much it has been displaced, depending upon the horizontal forces what we have provided onto the structure. So this
Okay,
kind of a
means based.
concept where exactly you just apply it is nothing but when you
Hmm.
are having any seismic forces, or
Hmm.
the best example is a wind force. Like when you have the wind force, you need to just know for the kind of the slender section what you have used for that structure. Maybe the height of the column is not 10 feet. Maybe it has been exceeded to 11.5 feet or 12 feet, like that, say. You need to know that extra
Hmm.
kind of that, member, like maybe it is 1.5
Hmm.
meter or 2 meter length, like how for the given proper loading, that is vertical load, for the given proper
Hmm.
horizontal load onto that particular node, how much it has been
Hmm.
displaced. So
Okay.
that is P delta effect is nothing but it's a secondary or second order effect, that it is called as a nonlinear part. Yeah.
Okay. Okay. Actually, in means when we have to means do linear or non-linear analysis, means if any structure we are analyzing.
Yeah.
Okay.
Yeah. Yeah.
So when means we have to means how we can decide that we have to go for linear analysis or non-linear analysis. Okay.
Yes, Sachin. Sachin, it is a slender structure. For example, see, I have a
Hmm.
case study where I have done, see, I'm a research scholar,
Hmm.
because I have developed a very critical kind of a section, that is, called the section to be a 200 by 150 as well as 150 by 100. That's very critical. So for that kind of analysis, maybe it is a 10 feet column, you can just apply the nonlinear analysis for that in that case. When you're just going on to the 300 by 300 cross section, okay, when you have the
Hmm.
column height of the 10 feet, definitely you can just go with
Hmm.
this linear methods. But what happens, it depends upon the
Hmm.
height of the structure also, right? So when it is a G plus 3 or G plus 2, I'll not talk about non-linear over there, because the not much of the wind forces which hits onto your structure, depending upon the various other buildings in your vicinity. But when you are just taking up above the 50 feet, I prefer
Hmm.
you to just go by the non-linear method.
Okay. When we perform linear analysis and when we perform non-linear analysis, we get responses in three directions. Means, okay, whenever you are applying any load, you will get some response in particular direction. So what is the difference? Means which direction, or in which direction we get the critical forces which are to be considered for the design in linear and non-linear analysis. I want to just have the difference. Means in linear analysis, we are
See,
getting the forces
yeah,
in particular this direction. We apply the load. Like, means, for example, if
no,
we are
that
applying load
particularly
on in
depends
vertical
upon
direction.
the symmetry. Sachin, sorry to interrupt.
Hmm,
That depends
hmm,
completely upon the symmetrical, or whether it's unsymmetrical structure, what you have just taken into the
hmm,
account.
hmm,
Suppose when you take a
hmm,
symmetry building, you can take it for
hmm,
plus X and plus Z, right? When you take a
hmm,
non-symmetrical,
hmm,
what happens? You need to just check from the other direction also how it has been deflected. When you just go into the load case types, when you just go for the particular,
hmm,
seismic load plus X, say like that. Okay, how is by what number of the displacement is your structure deflecting onto
hmm,
the
hmm,
right or onto the left or onto the backward, depending upon the plus side and the minus side. So that is how you can just interpolate with the values. You'll be able to just justify over there looking onto the
hmm.
scenario of those parameters.
Actually, means we are having means
Sachin,
our
yeah,
industry.
Sachin, it's okay. I'll just
Sorry.
take your name over here. Definitely,
Last question.
we can just also
Last
discuss.
question.
Yeah, please. Yeah,
Last question.
go on, go
Actually,
on.
we are having industries like last question.
Sure,
We
sure,
are
sure.
having industries like we are having industries like oil and gas,
Okay.
offshore, PT&D, power transmission and distribution, industrial, residential. Okay. So what do you think means non-linear analysis? Means this non-linear analysis can be done for these particular structures. We have to go for non-linear analysis only.
Definitely.
Do
See, if
you?
you're having an industrial structure, when you're using any
Mm,
standard sections like our code, ISHB, ISMB, call it to be a channel section or I section. Yeah, I just encourage by you just going by the nonlinear analysis because it is only a steel structure which is over there, right? You need to just know its convergence point. At what particular load is your I section deflecting by just that by you providing that number of that loads by the yeah. I would encourage you by going by you doing that nonlinear analysis for steel structures.
okay.
Yeah. Ah,
Okay.
Sachin, definitely will
Thank you.
connect. We'll connect after this session also. Anyways, I'll just leave my number also on the chat so that you can just also discuss. Or my coordinates are always on the LinkedIn. Also, you can just come up and randomly text over there and ask my details. I'll do that. But
Okay.
yeah,
Yeah, sure,
okay.
sure.
I'll leave it on to okay. You can just mute Sachin.
Yeah, yeah, sure.
Yeah, Harshavardhan. Harshavardhan Ja, please unmute yourself. I've allowed to speak. Harshavardhan?
Hello.
Yes, Harshavardhan.
Hello.
Yeah, you're audible, Harshavardhan. Yes.
Good evening, sir.
Good
I
evening.
have some request. Please provide the recording of the session.
Definitely, Harshavardhan. I'll do that.
Thank you so much, sir. This is a very important session, I think.
We'll also be having much more of the webinar series which is related to the nonlinear, particular to the P delta and also pushover analysis. Definitely, please stay in touch with me also once after we finish the
Okay,
session.
thank you so much, sir. Thank you so much.
Sure. Okay. Next, your Google Pixel 8. Okay, I don't know your name. I'm sorry, I just had to read your name that way. I'm allowing you to talk. Yes.
Am I audible?
Yeah, your good name, sir.
Yeah, myself, Dr. Ganapati. Sorry, I did not enter right.
Doctor?
Ganapati Patil.
Yes, sir.
I'm assistant professor in Siddhaganga Institute of Technology. So
Sure.
yeah, my question is one thing, and this ADCD, whatever you told, that is only for the concrete structures, or can we design the, can we understand the steel structures as well, sir?
Both, sir.
Both. Okay.
Yeah, both. Yeah, concrete as well as for the steel structures. Yes.
Okay, and just in general sense, you have come across might be you are experience also. In general sense, what all are the thumb rules? How can we understand various things in nonlinear analysis, and how we can interpret the results? That's what is very important for a structural engineer. So I
Yeah.
wanted to know how we can do that,
Yeah.
and what all are the things you consider as a thumb rule, general sense.
Yes, sir, yes, yes. I understand your question. The thumb rule is like, you've already got, in this previous, like, let me just move this slide for you if I can. This is the first form of the thumb rule, sir. Like when you need to just apply the different types of the analysis, which is related to non-linear static as well as non-linear dynamic analysis. That is one thing. And the choice of the material, sir. What is it kind of a material that you have chosen, so that you need to just perform this linear or non-linear is very important. And next is the material. If you're using a material which is of a cast iron, you definitely know at some kind of the yielding point it breaks. But when
Yes.
you are using any HYSD, as we have already seen in our practice, while we design, in RCC or when we design in our steel, so that has something of bending capacity at the, convergence. The convergence is nothing but at certain point it breaks. It has a virtue to break the cast iron. For example, HYSD, it tends to just elongate. So
Yeah.
in that way, I can just put you up saying that what kind of a material that you're using, for just use the nonlinear analysis. And also, as the height of the structure also increases, I call it to be like, it is a multi-story building, which is having maybe a 10-story building, or maybe it is a 12-story building. Definitely have to take the factors of the wind loads, like gust factors, and how exactly it will be just implying upon the structure in the sense upon the structural material. So in that way also you can just predict. And
Okay.
floor to floor height, sir. So that is also very important. Suppose if you're
Okay.
just taking a slender section, as I've already heard me saying that I have done my research in that columns. I have already,
Yes. Yes. Yeah.
yeah. In that way, I have found that bending over there, sir. I have found that buckling at exactly at the central zone, like, depending upon the loads what we have put. Definitely, we can contact after this call also, sir, since
No
Dr.
problem.
Ganapati, sir. Yeah,
Yes,
definitely.
sir. Definitely,
What
sir.
I what I'll be doing is I'll be just sharing my number onto this, and you can just have a
Yeah.
chat with me in that way. I'll do that, sir.
Yeah.
Yes,
Sure. Sure. You can share the email ID also, sir.
yes,
Yes.
yes, sir. Yes.
Yeah. Thank you, sir. Thank you, sir.
Thank you, sir. I don't have my office number at the moment. I'll be just sharing my personal contact. How can I do that? Just a minute. This is my personal number, but still, I'll just lend you out my office number too. I just need to search because I don't remember my office number. It's 924 92437 99936. Yes, sir. So, any other doubts? So, I'll just wind up in 5 minutes. Can I just expect any questions? Other questions from other attendees? Hope you have got my contact. You can please store, and you can just ask kind of the questions which is related to this STAAD.Pro as well as Structure Works Suite product.
Sir, did you send a message? Actually, we did not get it in
It's
chat.
in the webinar. It's in the webinar chat, sir. Didn't you get that?
Not yet, sir.
So kindly please check it once again. I'm just rechecking it again. Okay, now
There
is
is
it
no
visible,
number
sir?
in chat.
Okay, just a minute. So it is argav.s@arcans.world, and my number is 8123455621. This is my personal, and this is the second number is. I hope you are able to see that, sir.
Yes, sir. Yes, sir.
Yeah, this is my office contact. Yes, sir.
No, actually, your number was not there.
My number is in there, sir.
Yeah. Now I got it.
Now you got it, sir. Okay. Anyone has
Yes,
question?
yes.
I just see someone had a query also. Let me just. Okay. Okay, sir. Good to go. You have. I hope the participants have already. Okay, Akash. Abhishek has a question. Just a minute, Abhishek. Yes, Abhishek. Please unmute yourself.
Hello, am I audible, sir?
Yeah, you are audible. Please.
Yes, I wanted to ask, like, when do we go for P delta or when do we go for pushover? Like, can you give an idea about it?
Yeah. In the next webinar session, we'll be having that, sir, because I don't want to just mention more than the basic, but
Okay.
definitely I have a session of that. So please do attend that session. Definitely, I'll be just answering your question over there for sure.
Okay, sir. Thank you.
Yes, sir. Yes.
Bhargav, when you will be having this webinar on push or analysis?
For sure, analysis. Yes.
When you
Uh,
will be having webinar?
Maybe in maybe after a week, I guess, because I am also held up in a training for BL, Bharat Electronics Limited. So I'll be busy for there. So I'll let you know, sir. I'll let you know through the LinkedIn model. I am available on LinkedIn as Bhargav Srinivasa. Already you can also follow.
Okay.
So that I'll be just posting that link so that you can easily follow. So Bhargav Srinivasa.
Okay.
Yes.
Okay, Bhargav. Thank you.
Okay, thank you all for attending this session on this, and let me see you for the next P delta concepts, which will tend to be happening upon another webinar series. What we'll be having in future. Thank you. Thank you,
Waiting
Anand.
for this.
Thank you, sir.
Thank you,
Thank you.
Bhargav.
Sure.
Thank you very much.
Sure. Thank you.